I, Dr. Sandesh Kumar, welcome you all on the behalf of organizing committee, Chemical Research Chhattisgarh and School of Study. For this one, listeners will are on chemical safety. The chief guest of this Honorable Ravishankar and Dr. P. Pranath from Department of Chemistry, Banaras Hindu University, Varanasi. Head School of Studies in Chemistry, Pandit Ravishankar University, Coordinator, CRSI Local Chapter, Chhattisgarh, Professor Kallul Kumar Ghosh, and convener of this webinar is a Professor Manas Kanti Dev, and organizing committee members are Dr. Manish K. Rai, Swami, and Dr. Indra Karwal. Distinguished guest participants, faculty members, research scholars, and dear students for finding time and attending the today's webinar. As we know, in the past century, chemistry has increased our understanding of the physical as well as ability to manipulate it. The chemical laboratory for acquiring knowledge and using new materials use. But some are harmful to the women and the environment. When these students and research scholars enter in the laboratory for doing a standard procedure for handling the hazardous chemicals, the unavoidable serious existence. Thus, chemical laboratories have developed a special procedure and equipment for handling and managing chemicals safely and securely. The same, I would request Professor Kallul K. Ghosh, coordinator CRSI local chapter, for welcome address on this webinar. Thank you. Sir, after
thank you, Dr. Kamlesh. Now is all right. Now is all right. Very good morning and cordial welcome. Chief guest of this program, very important program, Honorable Vice Chancellor, one of the oldest and biggest university of Chhattisgarh, Professor Kesila Verma sir, the distinguished guest as well as a very distinguished scientist of our country, Professor A.K. Tyagi, the Associate Director of Atomic Research Center, Mumbai, the head of the department and chairperson of this seminar, Professor Shams Parvez, convener of this, my colleague, Professor Manas Kanti Dev, Dr. Kamlesh Sivas, other members like Dr. Manish Rai, Dr. Manmohan, a large number of students, because they are connected to the YouTube. You have a limitation in this Google Meet. I am saying some of the important faculty members of this particular area, like Dr. Prasanna Sharma and others. Ranchi, depends from. And it is indeed a privilege and honor you at this very important webinar. Organized, you all know that the Chemical Research Society of India, the founder President Professor C.N.R. Rao, now throughout the India, they are organizing the Chemistry Week. And under the auspices of this Chemical Research Society of India, we are organizing this very important seminar. And this is being organized by one of the most vibrant and active department of Pandit Ravishankar Shukla University, School of Studies in Chemistry. So I have no words to express my deep sense of gratitude to Professor KCL. In spite of this pandemic, corona problem, our university organizing not only the seminar, webinar, workshop, as well as the research course, induction program, and is due to the guidance and blessings of that. And you have put for the endeavors, not only for the chemistry department, for the development, holistic development of the field. We are also organizing the online classes and other things. We are proud, really, we are proud to have a very eminent scientist. I know that all the scientists of Baba Atomic Research Center, they are very busy. Not only their research work as well as the teaching, because he is a professor of this Homi Baba Center also. So really, he accepted our invitation. I just 2 days ago, I just sent an email to Professor Tyagi, and he accepted our invitation, and I welcome on behalf of the Ravishankar University and on my own behalf. And this is indicative of his concern and commitment to cause of safety and security problem. I think this second visit of Professor Tyagi, years ago, we organized the CRSI National Symposium, and that time Professor Tyagi actually delivered a important lecture, and he assured us whenever you need the help of me, you can contact. So we contacted Professor Tyagi. We also welcome another young scientist of our country, Professor KVS Ranganath. He will join, I think, at 11:30 as a keynote speaker of this conference. Contacted another very good scientist related to that chemical safety and other things. But I said Pune, Dr. Ram Chandra Bhatt, but due to certain other problems and other things, was unable to contact attend this very important webinar. And as you know that we have chosen this subject, chemical and laboratory safety. And we all know that whether we are a chemistry student or pharmaceutical branch of the physics and some of the chemicals. Some chemicals are very dangerous, artificial. Chemicals present a health threat for us and the faculty for working in the academic level. Maybe carcinogens, toxins, irritants, corrosive, and there are so many biological toxins are also available. And we all know we will not take much more time, because when I was working on some heavy water and DCL, there is a certain norms how to use. I have purchased this heavy water from the Baba Atomic Research Center and other things. Personally measure using the chemicals or how to handle the very sophisticated instrument. Dr. Tyagi will discuss about the safety in the chemical laboratory. Working in the Baba Atomic Research Center, you know what the importance of the radioactives, and Ranganath discuss metals. And I welcome all the participants that will enjoy this and beneficial webinar. Enriching academic preparation for one particular. So again, I welcome our Honorable Vice Chancellor, Professor Verma sir, and the distinguished guest, Professor Tyagi. Thank you very much. Kamlesh.
Nice introduction about the webinar. Now, I it's a conference chairperson and University for few words for this webinar.
Dr. Kamlesh, the respected vice chancellor. Okay, and respected our distinguished guest, Dr. Tyagi, one of the well-known premier institute of India. I think even across the world, it is one of the premier institutes. So it is our privilege that Dr. Tyagi joined the Department of Chemistry here in this webinar, enlightened us about the laboratory safety and chemical safety measures that should be taken by all institutions. So, moreover, I welcome the conveners and give my grand congratulations to the two conveners, Professor Kallol Ghosh and Professor, who dared to organize this webinar in this very busy time of examination and all these things. And just within a week, we discussed in a staff council Dr. Kamlesh and Dr. Ghosh's webinar, and we all accepted immediately. I think I have to congratulate a senior here. So, as far as the topic of this seminar and is concerned, that laboratory safety and chemical safety issues, what is going on in India? Every chemical handling process, transportation, all the things associated with the handling of any chemical and equipment, there is a standard operating procedures. What's happening in India? I don't know about the detail about the bar, because bar people are taking a lot of SOPs measures. But out of the bar, in India, in general case, in universities, in colleges, in many institutions, people are very much reluctant towards the following the SOPs. And the whole problem is arising because of not complying with the SOPs of handling of equipments or chemicals. Moreover, when I was in the US as a Fulbright fellow in the Desert Research Institute, when I decided to join the laboratory, so they asked me to go through an examination of laboratory safety and chemical safety. And I took about 15 days of training program, then I did an examination, online examination. And when I cleared that examination, after that, they permitted me to join the laboratory. You cannot join the laboratory, you cannot handle the chemicals. So I think same type of procedure should be there in Indian universities, Indian colleges, where chemicals handling and sophisticated instruments handling are there. We put to with that in this workshop, our vice chancellor is also here, because many times we used to meet our vice chancellors regarding to improve the SOPs of our laboratory, and he is smiling also because he always cooperates. We always used to speak, sir, we need to improve this electricity flow current, we need to make SOP, and for any SOP we need an amount grant from university. So every time he used to assist us and he support us. So after that, during this particular situation, this webinar is really very interesting, and I think our vice chancellor will also understand. Then whatever we told, Professor Ghosh told, Professor Manas sir told to him about the laboratory safety issues, he might be also understand here also more that yes, these SOPs are very much important for laboratory measures. So without delaying any with this program, I think we all are waiting for the delivery of Professor Tyagi. So Dr. Kamlesh, please go ahead with the further speakers. I think Vice Chancellor, I think then Professor Tyagi will speak.
Yeah. Okay, sir. Thank you very much. Before I ask Manas Kanti Dev sir, convener of this webinar, for saying few words.
At the outset, I must welcome, as a convener of this program, national webinar on chemical and laboratory safety. I welcome all the participants in that through YouTube and our today's distinguished speaker, Professor A.K. Tyagi from Bhabha Atomic Research Center, Mumbai, and another young scientist from Banaras Hindu University, Varanasi, Dr. K.B.S. Sarangan. And in fact, I must congratulate Professor Kumar Ghosh for organizing this very important program on chemical and laboratory safety at the Aegis, and which is being organized by Chemical Research Society of India, CRSI, local chapter of Chhattisgarh, in collaboration with the School of Studies in Chemistry, Pandit Ravishankar Shukla University. I am thankful to our Honorable Vice Chancellor for promoting us, doing such kinds of activities. And in fact, we are very happy to tell you all that such kinds of activities, since the emergence of this corona pandemic, COVID-19, lots of such activities we have been performing throughout this 8 months of course. So I'm thankful, and in fact, I must congratulate Professor K.L. Verma sir, our Honorable Vice Chancellor, for allowing us doing these activities. Also welcome Honorable Vice Chancellor Professor K.L. Verma sir to this program. Welcome the head of the department, Professor Shams Parvez, my colleague as the organizing secretary, Dr. Kamlesh Srivas, then the organizing committee members, Dr. Manish Rai, Dr. M.L. Satanami, Dr. Indrapal Karbal, all my colleagues here at Ravishankar Shukla Universities who are connected, all students and research scholars who are connected. I'm thankful to all of the people for joining us in this very important topic of webinar, which is connected to chemical hazards. Actually, basically presents physical or health threats. And after the emergence of this pandemic, the entire world has become a kind of laboratory. We are all wearing masks to protect ourselves, the biological hazard we are facing today. So I won't make any delay, on my part particularly. So straight away, I cannot be the speaker and all the recipients, audience. So thank you very much for joining us. For continuing this, please.
Thank you, sir. Thank you, sir. Now I invite Professor Kesrilal Verma sir, Vice Chancellor of Pandit Ravishankar Shukla University, Raipur, for this credential address.
Guest Professor A.K. Tyagi, Bhabha Atomic Research Center, Mumbai, Professor Kallol Ghosh, Professor M.K. Dev, Professor Shams Parvez, Srivas, faculty members, and dear participants. Good morning to all. I am happy to welcome you all in this inaugural national webinar on chemical and laboratory safety organized by School of Studies in Chemistry of our university under the auspices of Chemical Research Society of India, Chhattisgarh local chapter. I express my sincere gratitude to eminent speakers of the webinar, Professor A.K. Tyagi of Bhabha Atomic Research Center, Mumbai, and Dr. KVS, Rangnath, Banaras Hindu University, Varanasi for accepting our invitation. Due to COVID pandemic problem, our normal academic activities are affected. However, the Pandit Ravishankar Shukla University are regularly conducting various important academic programs, refresher course, faculty induction program, and webinars, etc. So, virtual mode. This webinar, Chemical and Laboratory Safety, aims to provide a platform to all the participants, particularly to the students and research scholars, to know about this important issue of safety. Chemistry is a very important subject, and we do use many chemicals, glasswares, and sophisticated laboratory equipments. Most of the chemicals produced and used today are beneficial, but some also have the potential to damage human health, the environment, and public enterprises. You must be aware of the potential for the accidental misuse of chemicals as well as their intentional misuse. Laboratories face a number of threats, including the theft of sensitive information, high-value equipment, or dual-use chemicals that may be employed for weapons or illicit production. Chemical safety and security can mitigate these risks. This is a very important subject. Before coming to laboratory, you must know the safety rules. A new culture of safety and security, consciousness, accountability, organization, and education has developed around the world in the laboratories of the chemical industry, government, and academia. Chemical laboratories have developed special procedures and equipments for handling and managing chemical safety and security. The development of a culture of safety and security result in laboratories that are safe and healthy environment in which to teach, learn, and work. I hope you will learn many new information about safety and security. I really appreciate the step of Dr. Kallol Ghosh, convener, CRSI local chapter, Professor M.K. Dev, convener of this webinar, Professor Shams Parvez, head and chairperson of the webinar, Dr. Kamlesh Srivas, organizing secretary, and other faculty members are organizing such event to provide an opportunity to listen and interact with such proficient scientists from premier institutes like Bhabha Atomic Research Center and Banaras Hindu University. I wish that all the participants will take full advantage of lectures and interaction time to solve their queries. I wish this webinar a grand success and wish all the participants to have a feast of learning, knowledge development, and sharing of experience. मुझे इस बात की भी बड़ी प्रसन्नता हो रही है कि भाभा एटॉमिक रिसर्च सेंटर मुंबई से मेरा संबंध कुछ वर्षों से लगातार रहा। जब मैं कमीशन फॉर साइंटिफिक एंड टेक्निकल टेक्नोलॉजी का चेयरमैन था तो मैंने कई वर्कशॉप वहां करवाए और स्वयं में वहां उपस्थित रहता था। भले ही उद्घाटन सत्र में जाता था और शाम तक किसी तरह वापस दिल्ली पहुंच जाता था, लेकिन भाभा एटॉमिक रिसर्च सेंटर के साइंटिस्टों के साथ बड़ा लंबा संपर्क रहा और उनके यहाँ हिंदी का कामकाज बहुत अच्छी तरह चल रहा है। हमने उनके लिए स्पेशल ग्लोसरी भी बनाई। इसलिए जब भाभा एटॉमिक रिसर्च सेंटर के वैज्ञानिक हमारे साथ प्रोफेसर अगर जुड़ते हैं तो अच्छा लगता है कि ऐसी संस्था जिससे मैं 2012 से लगातार जुड़ा रहा जाता था, बना रहता था। हमारे असिस्टेंट डायरेक्टर्स और साइंटिफिक ऑफिसर्स हमेशा वहाँ प्रोग्राम कराना पसंद करते थे और मुझे वहाँ उस प्रोग्राम में उपस्थित होकर बहुत अच्छा लगता रहा है। एक महत्वपूर्ण बात इसलिए भी कि हमारा स्कूल ऑफ स्टडीज एंड केमिस्ट्री बहुत ही महत्वपूर्ण विभाग है। हमारे ये प्रोफेसर्स लगातार शिक्षा में गुणवत्ता और इस प्रकार के सेमिनार और वर्कशॉप और वेबिनार के माध्यम से हमेशा रिसर्च और उससे जुड़ी हुई अन्य गतिविधियों को बढ़ावा देते रहते हैं और बहुत ही सफलतापूर्वक कार्यक्रम संचालित होते रहे। इसका मैंने अभी उल्लेख किया कि रिफ्रेशर कोर्स हो, चाहे वो फैकल्टी इंडक्शन प्रोग्राम हो, प्रोफेसर देव, प्रोफेसर संत परवेज, प्रोफेसर घोष और हमारे और टीचर कमलेश और सभी वहाँ के इस विभाग के शिक्षक और विषय स्कॉलर्स लगातार लगे रहते हैं और हमेशा कहीं भी कुछ केमिकल की चाहे एनवायरनमेंट की बात होती है तो हमारे प्रोफेसर्स अपने ओपिनियन देते हैं और समाज को उसका लाभ मिलता है। बहुत अच्छा लगता है। इसलिए ऐसे कार्यक्रम अभी आज दिन भर चलेंगे। हमारे साइंटिस्ट, हमारे प्रोफेसर, हमारे शिक्षकों को, शोध छात्रों को और हमारे स्टूडेंट्स को बहुत ही महत्वपूर्ण जानकारियां देंगे और सेफ्टी का, सिक्योरिटी का महत्व जैसा मैंने उल्लेख किया आज दिन प्रतिदिन लगातार बढ़ता है। हर संस्थाओं में, हर संयंत्रों में हमेशा सेफ्टी को प्रायोरिटी देने के लिए बार बार उसका उल्लेख किया जाता है, उसका डिस्प्ले किया जाता है और लोगों को लगातार अब इस पर ज्यादा अवेयर होने की जरूरत महसूस कराने के लिए प्रोग्राम होते हैं। इसलिए आप सबको और इस कार्यक्रम के जो संचालक हैं, अगुवाई कर रहे हैं और उनसे सब जुड़े हैं, आप सबको बहुत बहुत बधाई, धन्यवाद, जय हिंद, नमस्कार।
Thank you, sir, for nice address to this webinar. Before we welcome Dr. KVS Ramnath from Varanasi because he recently joined. So now I invite Dr. A.K. Tyagi, distinguished guest, for saying few words to this webinar.
Professor Verma, Honorable Vice Chancellor, Pandit Ravishankar Shukla, University Raipur, Professor Parvez, Professor Kalol K. Ghosh, Professor Manas K. Dev, and other dignitaries who have joined online and offline, participants, in particular young students, good morning to everybody. It's a great pleasure and honor for me to be part of this half-a-day event on chemical and laboratory safety. I must compliment organizers for selecting this very important theme, which is often neglected. As Professor Parvez mentioned in his remarks, that if you go to foreign countries, in particular to US and to Europe, chemical safety and laboratory safety is given paramount importance. What experience he shared with you while being in US, I also did share in my early 30s when I went for postdoc to Germany. They indeed conduct courses on laboratory safety. And unless you qualify these courses, that too with flying colors, not just by passing marks, they will not allow you to start the research work. This culture, something I highly appreciated, and at least in chemistry group of BARC and other divisions also, we are trying to imbibe this culture. Whenever we have young students, we do impart them some training. It is a time well spent. It's a good investment of time. It saves a lot of hassles in future if you don't do these things. Well, coming to this conference, it's a double pleasure for me to be associated with this half-a-day symposium for several reasons. I have a lot of association with CRSI right from its inception in 1989, as was mentioned by Professor Ghosh. Professor Srinath Rao is the founding president of CRSI. Since then, I have been associated with CRSI, and CRSI has been very generous to me. They honored me thrice in last about 15 years. They gave me bronze medal, silver medal. It so happened they also conferred on me Srinath Rao National Prize on Chemical Sciences. So they have been really very generous to me, and I have very fond memories of CRSI. Raipur also I have got very special connection, as Professor Verma was mentioning about BRC connection. I'm very, very glad to know that you have fond memories of BRC. Your interaction with BRC is not over. In fact, it should continue further. I look forward to welcome you to BRC at the earliest opportunity. Likewise, with Raipur also, I have a lot of association. Some of my best friends come from Raipur. In fact, one Dr. Ashna Sharma, who is a senior person over here, she was supposed to join this meeting, but at last moment, she got some other engagement. She comes from Raipur. And I very vividly remember my visit to Pandit Ravishankar Shukla University, Raipur in February 2018. This annual meeting, the mega affair organized by Professor Kalol Ghosh, I can sum up with one line. It was a flawless conference. Usually, you always say, ye nahi hua, wo nahi hua. But in this conference, there was no such thing. It was absolutely flawless. Coming to theme of this symposium, it is very important, very pertinent, not only for younger participants, also for any chemist belonging to any age group. Safety does not bother about age groups. So all of us should be always vigilant. See, nothing is hazardous if you know how to handle. And everything is hazardous if you are careless. Potassium cyanide can be handled in such a way that nothing happens. Whereas table salt, we know table salt is responsible for what kind of problems, because people don't know how to handle it. So more I will say in my talk. Let me once again compliment the organizers. Of course, let me once again convey my best regards to Professor Verma, Honorable Vice Chancellor, for this wonderful opportunity which has been extended to me to join this event online. Thank you very much.
Thank you, sir. Now we have a Professor Kallol ke Ghosh, coordinator, और short introduction पे Dr. Tyagi.
Without wasting time, we would like to start our technical program. Professor Tyagi needs no formal introduction, but large number of young faculty members are attending this webinar. So I must say a few words about the Professor Tyagi. Professor Tyagi joined Bhabha Atomic Research Center, Mumbai in 1986 through BARC training school. Since then, he has been working in the field of chemistry. If you refer his research papers and other things, he has been working on not only in the nanomaterials, functional materials, as well as the nuclear materials. He was a Max Planck Fellow at Max Planck Institute, Stuttgart, Germany during 95 and 96. Presently, he is head solid state chemistry section, chemistry division, and also a professor of chemistry at, you all know that, Bhabha, at Homi Bhabha National Institute. He has been published more than 600 research papers in international journals.
He has written 5 books, 12 book chapters, and few number of patents. In recognition of his work, he has been conferred with several prestigious awards, including the Homi Bhabha Science and Technology Award, the Gold Medal of Indian Nuclear Society, the CRSI Medal, Thrice CRSI Medal, Dr. Lakshmi Award by ISCS, ITS Award, RD Desai Award, and large number of awards. And most important is the Professor CNR Rao National Prize for the Chemical Science. He is a fellow of the Royal Society of Chemistry UK, the National Academy of Science India, the Indian Academy of Science, Maharashtra Academy of Science, and he has been visiting scientists to several countries, including Germany, USA, Canada, France, Spain, Sweden, Portugal, Russia, Japan, Israel, China, Singapore, Malaysia, and Australia, Italy, and South Africa. And he's a all gentleman. Just we sent an email to him, and he accepted our invitation. And really, we I have no words to express my deep gratitude to Professor Tyagi for accepting our invitation. Thank you, sir. Now I invite Professor Tyagi to deliver his.
Thanks a lot, Professor Ghosh, for your kind words of introduction. I'll just share my presentation.
Yes, sir.
So my colleagues are helping me. Okay. It's good. So are you able to see my PowerPoint?
Yes. But make it a
Okay,
full screen.
and you are able to hear me also?
Oh, yes. But
Yes. So once again, good morning to everybody. Today I'm going to talk on Today I'm going to talk on safety in chemical laboratory. Well, just isn't sharing good? Let's show you here.
make it a slide. Full screen में
Yeah,
sir. Please put in full screen slides.
But I have to do this only. Yes. So I again begin. Today I am going to talk on safety in chemical laboratory, which is a very, very important subject, and as I mentioned in my remarks, often neglected, which is not a very healthy situation. So let me begin for the benefit of young students with definition of safety. When we say safety, what does it mean? Well, safety is nothing but a risk management. We can also define safety by a process in which we can do prevention of accident. These two are the most widely used definitions world over to define safety in a chemical lab, or safety on road, safety in any walk of our life. How do we define risk and hazard? Risk and hazard are two terms which are interconnected. Hazard, it is a potential source of danger or harm. For example, potassium cyanide, it has a hazard associated with itself, and it does not change with time because KCN does not degrade just like that. What is risk? Risk is the probability of suffering from hazardous material, which can be reduced by knowledge of hazard and also by knowing how to do preventive measurements to stop the risk. KCN, for example, you can store properly, or you can convert it into innocuous form. I will show a slide towards the end of my talk. This way you can minimize or eliminate the risk of potassium cyanide. Risk is nothing but equal to severity of hazard into probability of exposure. So probability can be low, hazard can be high, its multiplication will be low only. Other way around, there is somewhat low hazard but high probability, that also can lead to high risk. But there are instances where we have got high hazard, severity of hazard is high, and probability also is high. These are the situations which definitely one has to worry about, one has to take care of the process to mitigate them. Its definition is, an accident is an undesired and unplanned event mainly caused by human error and or high-risk condition that results in or has potential for physical harm to persons and or damage to property and or interruption of business. In our case, business is nothing but chemistry. It may hamper the laboratories for weeks, for months, or even for longer time. That's how we define accident to that form of the event, and which is unplanned also. It just happens. Sequences of events which lead to accidents. So the nature of work is very important. Fault of a person is also equally important. A very sincere person can take care of a high-risk experiment also in a very proper way and nothing happens. But a person who is not so careful, not so experienced, even so-called simple experiments also may cause some damage. Unsafe act, unsafe condition. I will spend some time on both as I proceed further in my talk. So these things put together lead to accident, injury, and all this is highly undesirable. These things should not happen in your lab. Come what may, please ensure that these things should not happen in your lab. Why accidents happen? I have just made a slide. Of course, carelessness of a person, and it is not true that a young person is careless. A person who is somewhat senior in terms of age and position also at times can be careless, either knowingly or unknowingly. There is inadequacy in safety training. That's why we should impart training regularly to not only the new colleagues, also to colleagues who have spent some years in service. This culture in BRC is very much there. Every 2 to 3 years, we renew license of people who are working in the plants. Last week only in my division, chemistry division, we had renewed license of a number of colleagues who are working on high purity materials. Inadequate instructions. At times, young students complained that we were not adequately instructed, and that's why it led to problems. Unsafe experiments have to be done. I am not saying that we should not do unsafe experiments. We have to do, but then there should be extra precautions. Overcrowding of lab, overcrowding anyway. We are a populous country with high population. Overcrowding at times is inevitable, but we should minimize it. Inadequate equipment, inadequate facilities, misbehavior, not in a wrong sense. I am saying person is simply indifferent. I can call him a person who is not behaving properly. You cannot be indifferent in a chemistry lab. You cannot afford to be indifferent. Inadequate preparation, ignorance. Person does not know what he's going to do next, and that ignorance may cause a very expensive price to himself or herself and the colleagues around. Poor laboratory management is also another reason which often lead to accidents. I want to spend time on each and every point of this slide. Need for safety. Well, safety can cause legal implications. Very serious legal implications are waiting for people if they don't take care of safety. There can be court cases, there can be liability clauses, this, that, and it can really disrupt your daily life considerably. It has social implications. There can be a person who is the sole breadwinner of his family, and if something goes wrong with him, for the rest of the life, his family is in dire trouble. So it does have social implications also. Economical and social are interlinked. As I mentioned, person can become completely out of work because of some other serious injuries which he or she may incur during accident. So it has very serious implications of these three kinds. The stakeholders, well, the biggest stakeholder is you yourself, the person who is doing experiment in the lab. He or she is the most important stakeholder of benefit of safety or other way around, damage because of careless attitude. Colleagues, others, there can be an instance, a person comes to your lab only once in 2 years, and that moment something happens for none of his fault, just because of sheer bad luck, this person gets hurt. So we have to take care of not only ourselves, we have to take care of our colleagues, take care of our visitors, and so on. Responsibility, I must emphasize here, the primary responsibility of safety lies with the person who is doing experiment. He is most important. Individual supervisors, next responsibility lies with them. The PhD guides, the HODs, senior management people, they are also responsible for ensuring that conditions in laboratory are safe. Well, in this pyramid, I have just arranged the, of course, something has gone wrong with the slide, but not to worry, I will explain. All these symbols which you see, they had some English alphabets. So the base of pyramid is worker. In our case, worker is nothing but a young student. So he comes at the base. Middle level, we have got, let us say, supervisors. They are equally responsible for this. And top level, you have got the top management, the HODs, okay, the group directors. So when something goes wrong, everybody is held accountable. Nobody can wash his or her hand from any unsafe act. Safety in chemical lab, unsafe conditions are often responsible for causing problems. Unsafe chemicals, unsafe way of organizing them, electricity can cause accident, fire, gas cylinders, glassware. Glassware is also often responsible for causing accidents. Of course, in atomic energy, we have additional factor, that is radiation. Unsafe act of an individual or of group of individuals. Well, one has to adopt to safe work practices, waste management. I am referring to chemical waste management. Nuclear waste anyway we do in a very big way and in a very, very safe way. Layout of lab, labeling of chemicals, whether they are used, they are unused, they are legacy chemicals. We have to label properly, we have to segregate them. Accidents must be reported immediately. Housekeeping, there should be a first aid box readily available in each and every lab where chemistry is going on. Chemical hazards, it's very important before we start any work that we should collect MSDS sheets. That is nothing but material safety data sheets. I will show what are the typical contents of MSDS. Simple background to be known before analysis. Even if you are handling an like calcium carbonate, you must know a couple of things about calcium carbonate. What temperature it decomposes, what happens, how much CO2 will come out if I thermalize this compound. Analyze sample, and many experiments should be done in fume hoods. Don't do in open air, don't do in open air benches. Number of experiments where fumes are coming out should always be done in fume hoods. I think this is very important. Otherwise, you are going to inhale a lot of fumes which are highly undesirable, not good for your health. So please do work on fume hoods in case your reactions are having emanation of fumes coming out of during chemical reaction. Well, different labels. These labels are prevailing world over. No country can change these labels. These labels are accepted all over the world. Hence, whether you are in India or you are in US or Japan, once you see these labels, you know what exactly is the nature of chemicals kept in this bottle. The first one, for example, is nothing but indicating corrosive nature of the chemical. Second one is indicating that the chemical is carcinogen. It has got respiratory problems. It can also cause reproductive toxicity. Target specific problems can be caused. It may cause mutagenicity. It may cause genetic problems. Okay, like chromium 6. Chromium 6 is a very well-known mutagen. Aspiration toxicity. Third one, you can see a tree is there. Very easily you can make out why tree is there, and this tree does not have any leaves. It means this particular chemical can cause environmental toxicity. That's why it should be disposed in a very, very careful manner. Last one in this slide is indicating chemical to be an irritant. It may cause some irritation, some itching on the skin. It may cause acute toxicity, narcotic effect. Person may not be in proper order after inhaling these kind of chemicals. It may also affect our respiratory tract. We may have breathing problem. It may also cause irritation to us. So these four are typical labels for the classes of compounds, materials, chemicals shown in this table. Let me move forward. You can see this flame and some blank sphere is there. This is the label for oxidizers. Ammonium nitrate, KClO4, they are oxidizers. Second one, you can see a very big flame is there. This indicates that the chemical on which this label is affixed is flammable. It emits flammable gases. It can react itself or by heating. It is pyrophoric. It may have some organic peroxides. As a thumb rule, oxidizers and compounds in this category should not be kept close to each other. A very, very dangerous combination. Young students should never do this mistake, either knowingly or unknowingly. Here you can see in this label, there are some sharp nails coming out. As simple as that, it indicates compound can be explosive, it can burn by its own, it may be highly reactive peroxide. And third one is showing a human phantom skull. And you all know, of course, it means that this compound has got acute toxicity. Severest of toxicity, the KCN bottles have got this symbol. One has to be extraordinarily careful while handling compounds where this human skull, human phantom is kept fixed on the label. Here I must say, if on any bottle these labels got removed because of aging effect, because of other degradations, keeping in water and etc., we should immediately buy or print and affix them for other people. Please never ever see a bottle where we have got these labels which are in bad shape. You cannot see them, you cannot read them. You must take corrective actions immediately. There is no tomorrow for this. It has to be done today only. In fact, not today. I will say it should be done yesterday, a day before. Chemical hazards. Properties and hazard of the chemicals to be handled must be known. Very important. You must know what these chemicals can be causing a problem. Even if it is simple lanthanum oxide, yttrium oxide, still you must spend some time and to study it very deeply. One should obtain chemical history, background, where from this compound is coming. All these informations you must gather before you start the experiment. And many samples we get for analysis. You have a nice NMR machine, you have a nice FTIR setup, you have a nice XRD lab, you get 100 samples every month, which you are doing for others. Please ensure, if not daily basis, at least weekly basis, these samples are sent back to the users. Your lab should not become a place for storing the chemicals of others. Be a little selfish in this. Work is over, must call the person and give him back. Never ever accumulate samples of others, because this is, you are making your own house dirty out of muck from other houses. In case of spillage of chemicals on floor, it must be cleaned properly. As for cleaning also, don't use water all the time. For certain chemicals, water is forming a very, very explosive reactant. It acts as a reactant. So you must know which chemical should be closed. Water can be used for most, but not for all. Number one I can give towards the end of my talk, where water causes some problems. Fume hoods should be periodically checked. At times, fume hoods are very old and they don't suck. The fume hood is supposed to suck the fumes which are emanating out of the chemical reaction. And if sucking system, the suction system, the blowers, etc., are very old, their efficiencies go down. There's a term which is called as phase velocity. So phase velocity is nothing but a term which is used to express the suction capacity of fume hood. So you must always get phase velocity of fume hoods measured by a professional person once in 6 months, definitely, if not more often, so that you can take corrective precautions. So this is some message to young students and faculty members also. MSDS, I have been emphasizing for last 5 minutes to 10 minutes. MSDS provides you melting point, boiling point, flash point. Very important. A given compound should be heated up to what temperature safely, above which it achieves a flash point. Suddenly it is going to undergo combustion and there can be an explosive reaction. Toxicity levels, what is the minimum amount you can handle if compound is toxic? What are the health effects? And in case if you happen to inhale, what is the preventive measure? What kind of first aid should be adopted? One example I'll give you, since I used to work a lot on fluorides in my formative years, in my early 20s, at times HF, hydrofluoric acid, howsoever careful you are, it may fall on your hand, on your finger. Of course, best thing is to wear the gloves. If you wear the gloves, the spillage of HF, hydrofluoric acid on your hand, the damage can be minimized. But if suppose it so happens that HF has fallen on your hand, on your fingers, you must immediately go to dispensary, report to doctors. Doctor will give you at that point where HF has fallen an injection of calcium gluconate. Calcium gluconate is calcium compound which is water soluble. When you inject calcium gluconate on that part where HF has fallen, immediately calcium forms insoluble calcium difluoride, CaF2. Once these fluoride ions in our body, in our blood, they are converted to calcium difluoride. It is insoluble in water, insoluble in blood, and by human excretion, it comes out of our body. So you see how damage could be minimized if you report to doctor immediately. Reactivity, how to store a chemical, how to dispose in case of spillage, leakages, what are the countermeasures? All this information is available on MSDS. MSDS, those days, 86 when I joined BRC at the age of 22 years, MSDS, we have to spend time to prepare MSDS. We have to go to library, spend 1 week time or so. Nowadays, MSDS is available on internet. Just by double click, MSDS you can download for any compound. So please make best use of prevailing technologies and equip yourself with MSDS of all the compounds. Howsoever innocuous this may sound, you must get MSDS of this compound. Very important to young students as well as to faculty members. SOP. I think somebody was mentioning about SOP. I recall Professor Parvez, probably, or Professor Ghosh. Somebody did mention about SOP, and they also mentioned that Honorable Vice Chancellor is very much supportive of SOPs. He encourages SOPs. Well, friends, I must reiterate that SOPs are very important. A standard SOP, a standard operating procedure, is nothing but a set of written instruction, a step document. How do we handle a given chemical? How do we handle a given instrument? How do we handle a given activity? All these things are written in SOP. Development and use of SOP should be made mandatory. If it is not, please ensure that it is mandatory. It can be in the form of protocols, instruction, worksheet. It can have simple lab operating procedure. When SOP has following parts, it should have very well defined bold letters, title, and somebody should sign it. After all, SOP should be issued by a person of authority, person of knowledge, person of responsibility. That person only can write SOP. A young PhD student, we should not ask him to write SOP because he or she does not have experience. He may do so after 5 years, but not in the initial year of his career. It should have table of content, okay? And whenever you add something or remove something, you must clearly indicate. It should also have, in case of instruments, the method to calibrate the instrument, the method to standardize, how to collect sample, how to handle sample, how to make sample, how do we do analysis, What should be the time of run, let's say for FTIR, for XRD. So all these should be part of SOP of instrument. It should have health and safety warning. Very clearly it should indicate that while working on this instrument, while working on these chemicals, these are the probable health and safety issues, and you must take care. It should give you cautionary note also. It should indicate who is the qualified person. In case of any problem, a young student should know whom he or she has to contact. It should also have important phone numbers. If any problem is there, young student should know whom to contact. So these are the contents of SOP. Very important. SOP, I will encourage to everybody. We must have SOP of each and everything. Why do we need SOP? I will again re-emphasize. Definitely it improves and maintains the quality of lab. It helps to standardize the lab working practices. It is improving quality assurance considerably, and it inculcates a culture of safety. The theme of today's half-a-day symposium, half-a-day workshop, SOP is extremely important. It should not be taken lightly. What purpose SOP serve? It details the regular happening work practice, work process, which should be followed. It documents the procedure to obtain consistent quality and performance with safety. It is absolutely must. I have said earlier, and I say now also in chemical lab. For chemicals, for instruments, for everything, SOP is must. And there is no common SOP. How each instrument, how each individual has different fingerprints. Each instrument also has got different SOP. So don't have this impression that one SOP, how they say that one size does not fit all. Likewise, one SOP does not satisfy the need of all the instruments, all the experiments. You must have instrument, experiment, specific SOPs. It's very important. I must say this is also time very well spent. Please do spend some time on these activities. Advantages, as I mentioned, it minimizes the variation in results. You are more confident of your results. It ensures safety. It ensures long life of instrument. Often instruments become defunct because SOPs were not followed. Some people come and he and she mishandles the instrument. Instruments go bad, difficult to repair, difficult to maintain. A lot of money is spent in this process. A lot of efforts go. You lose the productive time in this process. In case of publications, these days, most journals are insisting, have we followed standard SOP, yes or no? If it is no, there are problems. So we must make SOPs, we must follow SOP, it's extremely important. I move forward, how to write SOPs. This is of course for faculty members and for seniors. Well, SOP should be very concise. It should be step by step. It should be easy to read. SOP is not a document where I should flaunt my English command. I should not use very complicated English words, because a young student who comes from vernacular medium, and I may mention, I myself come from vernacular medium till the age of 18. Yes, you heard correctly. Till the age of 18, I did not speak even a single word of English. So the students like me who come from this kind of backgrounds should also be able to understand SOP. So don't use Oxford English for this. I'm not saying anything against Oxford English. It is very, very high quality English, and I'm myself very fond of high quality English. But at the same time, for SOP, please don't do that. It should be very simple language. Information should be clearly presented. Grammar should be proper. Always use active voice in SOP. You must give instructions in SOP. Please do this. Please don't do this. Please switch on the instrument. Please switch off the instrument. Increase the voltage slowly. Decrease the voltage slowly. It should be in active and interactive form. Not too long. It should be simple, clear. And it is good to make flow chart. Flow charts are always easy to comprehend. So do think of making SOPs in flow chart and categorically write what are the do's, don't do's in any experiment. Safety committee, there must be safety committees in his department, because one individual may see anything from one angle, but you have to see anything from different angles. If you want to see a 360-degree picture of any situation, it it is good to involve more people. It is always good to have involvement of 4 to 5, 6 people in a committee, so that they can see from different angles. Department should appoint a knowledgeable, experienced individual for making SOP. A group approach, I have mentioned some time back, is better than individual approach. Some cases I will share with you hypothetical cases. Suppose one is working on autoclave. He or she is doing synthesis by hydrothermal method. Autoclave has become very old, 5-year-old autoclave. It has undergone a lot of wear and tear in last 5 to 6 years, and nobody is doing inspection. A situation may come that autoclave safety valve may undergo rupturing, and if like a pressure cooker valve valve also we change regularly. Don't we change? We do change. So autoclave valve, autoclave thickness of this container, autoclave lining, all these things we must periodically check, otherwise it will lead to a serious problem. Autoclaves do explode at times. There can be an individual who is not knowing much about experiment because he or she is just new. Of course, at times people who have recent experience, they also may have some ignorance. It may so happen. That's why we should read a lot. We should always see the safety instructions, etc. This person comes and he was using hydrogen peroxide for some reaction which he was doing in open beaker. In open beaker, you can add H2O2 the way you want. H2O2 will decompose and it will escape. Okay? Hello? In an autoclave, if you use excess of H2O2, this may decompose, evolved gases remain in the autoclave, and in this process, a pressure build-up situation comes, and autoclave may explode. That's why the person should be told thoroughly what to add, what not to add. So these are the typical examples, simply hypothetical, not to worry, these things don't happen. I don't want to cause any panic among younger students, these things don't happen, but there is a possibility. So it is good to be careful. Electrical hazards, though it is out of scope of today's talk, but I thought I will cover. At times in chemistry lab, electrical hazards cause accidents. So overloading of power point is strict. No, please don't do that. We in India have this habit of using multiple sockets. We'll buy multiple socket and put 3 or 4 plugs. I think don't do in lab and don't do at home also. So this is a very, very unsafe practice because power points are getting overloaded. Any non-functioning, defective electrical electronic equipment should be disconnected immediately. No tomorrow, no today. It is yesterday. Okay? Switch off the power at the end of work and pull the plugs out before leaving the office, especially on Fridays. If you are not working on Saturday, Sundays, please pull out the plug. Lab should have excess space all throughout. Otherwise, access can become an issue in case of emergency. So there are some simple guidelines I thought I will share with you. Hazards due to gas cylinders are also very serious. Gas cylinders should never be kept close to furnace. Gas cylinders should be kept away from furnaces. The furnaces may cause some heating, and heating may cause expansion. Expansion in turn will cause pressure buildup. They should be kept in a cool, dry, and well-ventilated places. Gas cylinders should always be kept on the stand, and you should tie them with chains. Don't tie gas cylinders by chain, and that may cause some issues because gas cylinders can topple. So, and other thing is that while carrying gas cylinder from one lab to other lab, don't roll, don't drag. It should be transported with the help of trolleys. So you should mount gas cylinder on a trolley, and trolley has got a chain. You should close it, and then you must transport it. Rolling of gas cylinder can be very dangerous. It will layers of gas cylinders don't work after their work. That's why you spend memory. And in any it is not lesson. In LPG, LPG to glassware. We just cannot afford. Chemistry is an experimental science, and most experiments are done in glassware or in quartzware. So the thumb rule is that work area should be uncluttered. All glasswares should be handled properly. They should be at chemistry lab, you must enter and you should be fully focused on your experiment. You should always wear protective gears. If you work on some hot thing, suppose you are handling hot stuff, in that case you must wear silica wool gloves. If you are working on HF, you must use plastic gloves, rubber gloves. So these are the simple practices which we should imbibe. You can also wear helmets in case of other more risky experiments. All these things should be available right at the entrance of a lab. Housekeeping. Housekeeping is an area very important integral component of safety. Unless we do regular housekeeping, safety cannot be ensured. The workbench should be kept clean at all the times. Don't clean only when a visitor is coming. Often we have this practice. If the HOD is coming, so young student will say, let me clean the lab. No. Whether HOD is coming or not coming, the lab should be clean all the time. Before you leave lab for your home, you must clean it. Paper waste, plastic, glassware, food items of course should not be kept. You should dispose them properly in separate bins. Don't mix them. Segregation of waste is very important. Always keep PPEs in the lab. PPEs now, of course, it is becoming very common because of this pandemic situation. But PPEs in labs are always there. Never remove any equipment from the room without the prior permission from concerned authority. You should not say, I will remove it. The authority should be known about this. And if you are leaving unattended any experiment, you must ensure that some warning sign is indicated. Suppose you are doing refluxing and you go for a cup of tea, you must put a signboard, refluxing is on, be careful. So a person who is coming to this lab for some other purpose should not by mistake damage the experiment or harm himself or herself. That is very important. Next is continues. Never dispose of any solid waste into sink. At times, people think that sink, let us dump it there and open the tap. It can cause a lot of problems because many chemicals, many products which you synthesize, they interact with water and create a lot of problems. If you are working on chargogenites, if you put them in sink, they get hydrolyzed. A lot of foul smell comes in this process. It causes problem. It causes irritation to you yourself and to your people who are in neighborhood of your lab. So please never ever dump anything to sink. Sink is not the place for dumping chemicals. Remember to turn off the water supply when you go home. Ensure that water supplies are closed, gas cylinders are closed, lights are off. Never leave anything open. If you are last person, it is more important. So, but learn a habit of becoming last person from the lab. Last persons are more responsible and they do more work also. So they spend extra 1 hour or so. Considerably, electrical fault facilities, LPG should be properly checked periodically. And of course, I must admit, when we crowded in our country, that we should not be careful. Or that laboratories are not overcrowded. We should have proper layout. Nowadays, layouts are available on internet also. More and cost heavily in case event. All the labs should have peeping windows. Very important. Here, one can see from outside. You may not be in the lab at present. Security person is there in your university, in your organization. On the duty for entire night, he may so security person outside on the contact details. In case of emergency, case of problem during odd hours, be able to contact you very easily. find a user who may find it useful. If it is not there, as a chemist should know how to degrade it. And if they are unlabeled chemicals, be extra careful. Try to identify what is the content of this unlabeled bottle. Is it chemical? I can give one example. You have, let us say, KCN, a small amount. You can make some chemistry and degrade it. I'll give one example in a short while from now. You can take care. Suppose you have mercury. Mercury spillage is very common at home also. Mercury spillage can happen in laboratory as well. You cannot be mitigated by putting sulfur powder. Itself, mercury reacts with sulfur. It forms HGS. It is what we used to read in our 12th class of chemistry. Soft interaction. Mercury is soft. Soft interaction takes place at room temperature, and mercury, which is difficult to broom, mercury becomes a powder, and you can broom it very easily and get rid of it. Of course, after you collect mercury, don't dispose in sink. Mercury is highly toxic heavy metal. It should not be disposed in sink because it is going to pollute the water bodies if you do that. Classification of waste. You must know the nature of waste. Flammable, solid, liquid, gas. Waste which is highly incompatible with water. Don't put water on that. Oxidizers, nitrates, corrosive, toxic, organic peroxides, explosive, compressed gases, cryogenics, biomedical. And in our case, we also have radioactive waste which you may not have. So you must know very categorically the nature of disposal. You must recognize that there is a need to dispose. You must assess, you must minimize, and then you must prepare yourself how to do disposal. It is called as ramp approach of disposal. You must do documentation, regulations, and you must educate yourself and you must educate others also. Cosmetic maintenance helpers to do disposal. They are not knowing much about chemistry. Disposal is to be done by chemists only. You cannot ask a person who is involved in cosmetic maintenance. He or she cannot dispose your chemicals. Please never do this mistake. You will do that at times. Special rules, of course. You can do neutralization. You can convert to non-toxic form. You can precipitate. You can make a compound. I told you sulfur. You can make sulfur sulfide. Sorry, mercury. You can make mercury sulfide, and you can make less toxic form of mercury. So guidelines, anyway, I emphasize, you must follow guidelines, very important. Chemical waste, disposal guidelines. I can give 1 hour talk on this itself. Just to very briefly show one slide. First, you must know the nature of waste. Is it innocuous, aqueous waste, acid, alkali, harmless soluble compounds, salts, for example, alcohol-containing salts, hypochlorite, talc grade. These chemicals you can wash in large excess of water. Say 1:1000 ratio can be used, and then you can mitigate them. You can get rid of them. monosilicon compounds, metal phosphides, phosphorus-based compounds, fluorides, nitrites. Be very careful. You should call specialists. Solid waste, of course, can be glue, tissue rolls, wires, centrifuge. Don't dump them into dustbin. That it can lead to problems at some other stage, at later stage. These things should be disposed very carefully. Disposal of chemicals by high temperature incinerator. We have one, and as I mentioned, PRC. So it has got different stages. First stage is here we do pyrolysis. In primary combustion chamber, all these chemicals, organic ones especially, are heated at 800 degrees centigrade. Next stage is secondary combustion. Temperature increase from 850 to 1100. At this temperature, all these organic compounds decompose to carbon dioxide, water, CO2, of course I mentioned, and you can get them mineralized. Then we use scrubbers. Scrubber is here. It goes to chimney, and chimney has got long height. From chimney, you can release in atmosphere. But before releasing, you must do analysis of exhaust gas. It is very important that you don't contaminate the air by this process. So exhaust gas analysis is a regular practice. It is done on daily basis in a chemical incinerator. Otherwise, we may cause more problems. Likewise, one typical example of cyanide. Of course, don't do immediately. You must get good practice of this. You can react KCN with KMnO4 and convert to KCNO. So KCN little dose is 5 milligram per kilogram. KCNO is 840 milligram per gram. So you can see its little dose is considerably. It becomes quite harmless, but not as for CO2 and K2SO4. You see how by simple protocol you could mitigate KCN. But if you want to dispose KCN by this route, please take utmost care. Please work on a very small scale, and please do in the presence of experts. I will not recommend PhD students to do this protocol. That I must emphasize once again. It should be done really well-trained people. Fire tetrahedron. Fire tetrahedron is very popular concept. One apex of the tetrahedron is occupied by oxygen or oxidizer. This side is fuel. This side is heat. This chain reaction. So these three things are very important. They are in the base of tetrahedra, and this apical corner is the topmost corner. How do we get rid of fire? You have to stop one of them. If you can stop oxygen, oxidizer, then control the fire. Fuel, you can control the fire source. Fire. Of course, many times when fire starts, so it propagates by its own. So this tetrahedron policy is, the guideline is used to minimize the propagation of fire. Classification of fire. Fire is globally classified into four forms, classes, A, B, C, D. Secondary combustible materials like paper, wood, clothing, furniture, plastic. B involve flammable liquids like ether, hexane, gasoline. C is fire caused by electricity, caused by reactive metals like sodium, lithium, metal hydrides. So you have extinguishers for fire. To find out which type of extinguisher is to be used to douse a given type of fire. Very important training which everybody should take irrespective of the age or position. Yes, I have mentioned several times. Now comes very important slide. It is called as Battery box model. My attitude affects my behavior. Agree? My behavior affects your attitude. I think you again agree. Your attitude affects your behavior, and your behavior affects my attitude. So, young friends, we all are interlinked. Unless we all are careful, laboratory and chemical safety cannot be ensured to seal-proof level. Even if one person who has a wrong attitude, a wrong behavior, professor has to have right behavior to minimize, to mitigate the accidents in chemistry lab. Some references you can see in more details, whatever I discuss in today's talk. I must thank my colleague Dr. R.K. Singhal, who is a colleague of mine from Analytical Chemistry Division. A number of other colleagues also are thanked. I have taken a lot of inputs from them. More than that, my own experience, as it was mentioned while introducing me, I joined BRC in 1986. I was pretty young that time, just 22-year-old young boy. So my more than 34, 35 years of experience also had taught me many things. I must thank the organizers, in particular Professor Ghosh, Professor Dev, Professor Parvez, and of course, Honorable Vice Chancellor, Professor Verma sir. Thank you very much.
Thank you, sir.
Camera mode.
It was a wonderful talk. Wonderful talk.
Wonderful talk, yes.
Stopping the
Very wonderful thought here, and it really energized all of us and threatened us to immediately rush towards the laboratory safety program. So, can you provide us a detailed guideline of safety, laboratory safety and chemical safety, so that we can implement commonly in our laboratory?
Don't keep a stock of the solution. Make it when you need it, and minimum amount. No need to make 1 liter solution of mercury and keeping in the lab. Is concerned, mercury spillage, I give you an example. If it is mercury, immediately we should put sulfur so that it becomes a less harmful compound. So these are some precautions which one should take while working on mercury. Let's go some on that day only. 5 ml. What is the current potential of radioactive waste in India? I must say only one thing, that professors, we will show you the state-of-the-art level facilities for nuclear waste management, how safe it is. And nuclear waste is a big source of wealth. All anti-cancer treatment cancer diagnosis is done by using radioisotopes. If there is no technetium-99m diagnosis, nuclear waste, please don't have this feeling. It is a waste which has got incredible wealth also. Please do visit us sometime. We'll be very glad to show you the kind of facilities which we have got. Okay, some people want my PowerPoint file. I will send to Professor Ghosh immediately.
Yes, sir. I have one question. Sir, I have one question.
Professor Ghosh, please share with all the participants.
Yes. Immediately, I will share all the parts.
Can I ask one
question from Fine, you are asking what are the possible valuable products can be produced from radioactive waste. Well, as I mentioned, radioactive waste has got 40 odd elements in different isotopic form. 37, one example, cobalt 60, they are used for gamma radiation, agriculture, food radiation only, which we get from nuclear waste. So this list is very long. Please visit BRC website. RU106 has been developed treatment of ocular cancer. For eye cancer, RU106X have been developed by our department, DARC, and used these days. So there can be many examples. A separate talk on this. I have got a dedicated talk on this topic, which I am very happy to share with you. Yes, Suresh, I will share the presentation.
Let me ask one question. In fact, this is not entirely related to laboratory chemical safety, but it is something to do with when we go for some X-ray, like chest, PU X-ray. So techniques very actually, because these are not the normal radiations actually. So it is all the time, kind of worry with the patient that how much exposure should be there. So these things should also be taken care about, I think so.
Yes. Though it is not part of my talk, but I have separate talk for this.
Right. That's what I told earlier.
I fully agree that because of negligence of a technician, you should not undergo chest X-ray 10 times. It is definitely not advisable. That's why it is good to go to good laboratories, radiological laboratories where people are experienced. I fully agree we should minimize it. At the same time, exposure time is so small. So I don't think that there is any serious worry for this. Exposure time is very small and it is done with utmost care also.
Dr. Tyagi.
Yes.
Can you recommend that any new colleges or universities should we start without following the standard operating procedures of safety measures? Will you recommend this? Will you recommend?
If I understood your question, you are asking about SOPs.
Yeah, because lots of colleges are because just today I have to go to college inspection, but I cancelled that because of this program. So they are starting BSc program or BSc, and definitely there will be chemistry laboratory. And what in ground reality, what is going on? Government is not giving so much grant. They are just focused on starting new colleges, science, MSc, BSc courses, and they are not giving so much high grant. And at the same time, the colleges are starting courses. So without any, measures, safety measures, they just bought some chemicals, some instruments, and started analysis and dumping all the chemical waste in a river on nala, water, like that. Or just tap water they are using cleaning the laboratory. So whether will you recommend that without any following the SOPs of safety measures, government should not open new institution laboratory?
Professor Parvez, your question is very valid, but unfortunately, definitely, I am not the authority to issue this kind of instruction.
If you will recommend,
but there should be some mechanism. What I would suggest, the easiest to implement is that at university level there should be proper safety committees.
Yes.
I think if the safety committee is in place,
yes, correct.
Then this point can be taken care of. Like in our department, we have different levels of safety committee. Safety committee at division level, at group level, at department level, and they do safety analysis of each and everything before they give safety clearance. It should be done definitely very seriously, but at the same time, we are not the authority to issue instruction on this matter. The authorities at college level or university level should constitute safety committees, and they should empower safety committees. See, if you constitute a committee, it is important to empower them also. So they should have proper power also to stop a given lab if they are not satisfied with safety conditions. So it is done best. It is best done at that level.
Okay, great. So because Vice Chancellor is here, so that's why I'm asking that whether you are.
Yes,
so it's good
in fact, I will request to Honorable Vice Chancellor sir that safety committees should be in place. Very important.
Very good. That's great. Thank you so much.
Most welcome.
Yeah.
So number of requests are there for sharing my PPT. That I will do anyway.
This session because
of you.
I'll share, right? Participant, they can directly write to email to Professor Tech because the shortage of time.
Yes, if you have any pointed query, please drop me an email and I will definitely answer. I was in BRC for 8 months of safety rules. I am very happy and good.
That I have published three research papers from BAR.
Oh, wonderful.
And he's an undergraduate.
With whom she worked?
Three very good research papers.
Vidya, with whom you worked?
Dr. Prabhat Singh, Education and Chemistry Division.
He is from chemistry group only.
Yes, sir.
Message, very informative and relevant talk. And tomorrow I am giving a talk for CRSI Jaipur chapter.
Chemistry and opportunity, I think.
Yes, career prospects in chemistry.
That is also very important. CRSI is now.
As I mentioned, with CRSI, I have got a very fond association.
So Professor Ghosh has chosen a very relevant topic, especially for the universities and the colleges, and Professor Parvez has raised a very valid question. Should there be some guidelines from the government itself so that we can follow those guidelines?
Yes, sir.
And I will be very happy to help you.
Yeah, thank you, sir. Thank you so much.
Okay, sir. Thank you very much for an informative talk on safety and chemical laboratory. Now we have another remote speaker from the Department of Chemistry, Varanasi University, Dr. K.V. Rangnath. Dr. K.V. Rangnath. So before he starts, I shortly introduce his career. He is a state professor of science department of the chemistry university, and he did his PhD from Indian Institute of the Chemical Technology, Hyderabad, and he did his postdoctoral from Japan. He also did postdoctoral fellowship from a Münster University, Germany. And his research interests are surface modification of nanomaterials and their application, and also synthesizing a new functional material like metal oxide, carbon nanotubes, nanofiber, graphene, in all application. And he has published in several renowned journals like chemical communication, green chemistry, catalysis communication, and chem catalysis chem and JAX. So these are a highly impact factor journal. He published his work, and his awards are JSPS fellowship. So this is a very prestigious fellowship from Japan. A Humboldt fellowship he done 2008 to 11. So this is also a prestigious fellowship, and one big fellowship that is from India, Ramanujan fellowship from DST, and he currently completed two projects, and he has already completed two projects from DST Serve and DS3 nanomission program. So now I invite Dr. KVS Rannath. Hello, Rannath sir.
Where is Professor Rangnath?
Thank you very much, Dr. Ross. Can you hear me?
Yes, yes.
Okay. First of all, I would like to thank Honorable Vice Chancellor sir and Senior Professor Kallol Ghosh sir for giving me this opportunity to share some research experience about the safety in the laboratory. Also, would like to thank Dr. Kamlesh.
We have to remove Professor Tyagi. Professor Tyagi should remove his.
Rannath sir, please on your video, sir. Rannath sir, please on your video.
Yeah, it is on. It is in the on. Oh, 1 minute. Sir.
ये हटाया क्या इसको? त्यागी साहब का पीपीटी दिख रहा है?
ये सुनो ना, क्या बोलते हैं ये जो
What happened, Dr. Kamlesh?
So he
हाँ
is continuing, sir. Continuing.
क्या प्रॉब्लम है? कुछ आ नहीं है? Yes, Ranganath, now it is all right.
Yes.
Now it, yes, very good. Ranganath sir, yes.
Sir, is it clear now?
Yes.
Yeah. And please coming. Full slide. Please put in full slide.
Yeah. Yeah, very good morning, all of you. Today I would like to at particular temperatures. Yeah, the temperature is changes, so it is the viscosity is going to change, and at the particular temperature, how the surface tension of a given change, and every type of the materials, every type of the material information, you can get it from this site. And before handling of any chemical, just go to this site and type your chemical name, and then you can get some kind of the information. Then its own number, that is known as a unique identity number. Similar, just like our human beings are having the each human being is having some kind of the fingerprint. It is not matched with any other person in the world. Similarly, having its own identifier number, that is known as the CAS number. Chemical, you should know before doing any research in the laboratory. If you type that number in the chemexpert.com, full details of that chemical will come. Examples like so many physical properties of that chemical is going to appear on the website, and just see that chemical properties, and even sometimes they can provide the spectra, the IR spectra, NMR spectra, and some kind of the expect molecular weight, and we can get the HRMS if it is possible, and whatever it may be. Full details of the chemical is available from this website. And before going to before going to handle any kind of the chemical, just go to this website and find out. You can type either their trivial names or IUPAC names or genetic names, whatever it may be. It can of the chemical. And also, if the chemical is having the two enantiomers or the two isomers or two stereomers, whatever it may be, two stereomers are also having the different kind of the numbers. For example, if you take the D-glucose and L-glucose, they are also having the different kind of properties, physical properties. So it is going to display two different numbers. It is like a unique identity number for each chemical. Even water is also having some identity number. Some even if you take the copper sulfate, it is having the one number. Even if you take the copper sulfate hydrated molecule, it is having another number, because of its properties. Physical properties are going to change when the molecule gets hydrated, so that you can get the complete details of that chemical before entering into the research laboratory, or any other laboratory. Okay, then just now Professor Tyagi has described about the material data sheet importance in the laboratory before entering it. like 30 to 40 years ago, it was named as only the safety data sheet, that is known as the SDS. Then after that, it has been converted into the renamed it as the material safety data sheet, MSDS. MSDS, this can give us proper information about the health, what is the health hazardous, what is the precautions to be taken in order to handle the chemical very carefully, and what is the environmental health, how this chemical is going to affect the environment if we do not handle it. What permits we need to take, safety precautions to handle storing, and also when transporting one such and reactivity and this information we get from the chemwatch.net, and you can you can go to this website and you can log in. You have to register just like our the Gmail. You have to log in, provide the login, user ID and password. Then after from the next time on, from later onwards, you can get it type with that chemical and you can get the full information of the material safety data sheet. So whatever it may be the material, whether it is a solid, liquid or gas or any kind of the material, we can get what type of that particular material is having. And also we can get what is its freezing point, what is its flash point and boiling point. So that when we are doing the reaction, some reactions, sometimes it is required to go to the negative, means below negative temperatures, that is the -20, -30, -40, and sometimes to see. If you go to this website and you can find out the material data sheet and also product safety data sheet. Product safety data sheet is also a very, very important. Here the product, that means that once whatever the molecule, for example, you are synthesizing some molecule, then if you want to save, if you want to store that one, okay, what type of the materials you need to use, whether you have to use it in the plastic containers or glass bottles, or it should be keep it under the dry ice, or what type of the containers we should use for such a kind of. Suppose if we order some chemicals, we can get it in the plastic bottles, not in the glass bottles. If we order some other type of the chemicals, our chemical person bring the chemical in the thermally isolated systems, like using the carbon dioxide and some other things they have by protecting, by using some under the coldness, they will bring the supply. They supply the chemicals to the laboratory. That gives you the if you want to supply some chemical, if you prepare some chemical in your laboratory, if you want to supply this chemical to some other institute, then what type of the precautions to be taken care. That is the product safety data sheet. You can also get it. And actually, this material data sheet can give some kind of the procedures, how to prepare the chemicals, and from what is the steps are required to prepare the chemicals, and where we can get the chemicals, and also once the chemical is received, and what is its solubility, in alcohol, what is its solubility in water, what is its solubility in the hexane, like the solubility in the polar solvent and solubility in the non-polar solvents also we can get. And also, not only that, for the physical chemistry people, it is necessary to understand the partition coefficient and the distribution coefficient. For example, if you take the alcohols, like a 1-butyl alcohol, 1-pentyl alcohol, or if you go for the higher alcohols, it is necessary to understand what is its partition coefficient. So, why it is necessary? Because sometimes we are doing the reactions in the mixture of solvents, alcohol and water combination, alcohol and THF combination, and alcohol and some ethyl acetate combination, some combinations, some biphasic reactions also we are doing, some water and toluene, water and THF, water and some other solvent. So in such a cases, we need to understand what is its partition coefficient and what is its distribution coefficient of a given component. So that we can also get these kind of the information from the material data sheet, and also we can also get the hazard evaluation related to the product handling, storage, how we can store these compounds for a long period. Is it required to store it for a long period, or it is can be stored only for a short period, which can cause the environment, which can poison. If we store it for a long period, maybe it can poison the environment, or some kind of the effects also can be given in the material data sheet. Okay, we can also see what is the pH of a particular compound, and after dilution with the after dilution also we can see what is the pH range of a particular compound is also given in the case of the alcoholic compounds. It is not, pH is not given for all the compounds, particularly it is available for the alcoholic compounds and acids and bases, some kind of the bases you can get what is its pH range when we dilute it with some other materials. And also it can also provide the chemical potentiality of a given compound. Chemical potentiality means the potentiality of that compound when the compound is present alone, 100% pure. When it is 100% pure, it is having some boiling point, it is having some melting point. When the same compound is mixed with some other chemical, its melting point, boiling point, and freezing points are going to change. Okay, sometimes we can get that data also. If the material is like 100%, we can get the boiling point something. And this material is, if it is like a 97%, 96%, its boiling point and melting points are also going to change. So in some particular compounds, we can get, using the material MSDS data sheets, we can also get that information. What is the purity of the compound? What is the percentage of the impurity, and how the boiling point is varying when the percentage of impurity changes. That kind of information also we can get it from the MSDS sheets. And now, particularly in my today's talk, we would like to discuss something about the hazardous material. So, what is the hazardous material? If you see if you think what is the hazardous material, any material which is the flammable, and any material which is a corrosive and highly reactive and highly oxidizing and toxic and carcinogenic. Okay, and these kind of the materials are known as the hazardous materials. Not only that, if you take any material which breaks down into the highly oxidizing material, that material is also known as a hazardous material. And these kind of the materials dangerous not only for the humans but also for the environmental point of view. So, for example, if you take the acetone, THF, methanol, and these kind of the materials are highly flammable, and also nitric acid, one normal nitric acid, sulfuric acid, bromine, these belongs to the highly corrosive materials. And so when you are taking the acetone and THF and some kind of methyl alcohol, okay, these kind of the materials, these kind of the solvents, you can use it for maybe 1 year later or 2 years later. But when you are using the THF, you should test the peroxide, whether the peroxides are formed in the THF or not, because it causes more and more explosions, or maybe it can cause some serious injuries in the laboratory. If the THF is kept long period for more than 2 years or 3 years, it can form some kind of the peroxide. So these chemicals better to keep always in the inside the cupboard. Okay, don't try to expose even towards your tube light. Just don't keep the THF, particularly THF. Don't keep it outside for just for a long period, or even if it is exposed to the light, tube light, it can generate some kind of the peroxides even after long run. Not immediately, maybe after 2 or 3 years. Because some students, some senior students purchase a THF like a 2.5 liters. If they kept on the cupboard and they do not use it for a long period for 3-4 years, then once after certain time, junior students want to use that THF. Okay, you can see some kind of the peroxides may be present in the THF. So that is the, before handling of that, better to keep the chemicals carefully inside your cupboards. Okay. Then the term, another term, that is the Hazcom. Hazcom is came into the picture, which is this is the one of the technical terms developed by the American Chemical Society. So this from the Hazcom is the information provided. It should be the provided to the about the chemical hazards before entering into the research lab or UG lab. Okay, people should know what kind of the injuries they are going to face when they handle the chemicals in a wrong direction, and also people should know what is the seriousness of that injury and how it is going to affect their internal organs like kidneys and others. So this is a very important phenomena before United States of America has developed one term that is known as a HUSCOM. Okay, that is this HUSCOM is now collaboratively working with the GHS, that is globally organized system, and these have this is having the two kind of the safety branches. One is the EHS, and another one is the EHS means that is the environmental healthy safety, and then second one is the personal healthy safety. That is the personal. The students or the researchers who are working in the laboratory, their safety is also important. At the same time, environmental health safety is also very important. So two branches of the safety instructions are now being developed by the American Chemical Society. One is for the personal safety and another one is for the environmental safety. So these two are the separate branches and have been developed and they are working parallelly together. When the one person is entering into the lab, they are giving the training to the personal safety and at the same time environmental safety. So these two branches of the safety instructions are combining directly and giving the importance of the importance and guidelines for the safety data sheet, and not only for this definition of the hazardous chemicals and also about the classification processes and all these things. So now I would like to discuss briefly about what is the HUSCOM pictorial diagrams. Okay, HUSCOM pictorial diagram is, first of all, it is a red color square mark. Okay, whatever the chemical is we are going to use, that should be, because in our olden days means it is like a 20 years or 30 years before, when you want to handle any chemical, they have given the some kind of precautions. You use this chemical like this and this. You store this one. You have to handle this one. So many parameters they described on the paper and they should send. Okay, nowadays they are not doing all the things. They are doing just simply one symbol. We should understand what is the nature of this chemical, whether it is oxidizing a chemical or whether it is a corrosive chemical, whether it is a explosive chemical or whether it is flammable or whatever it may be. Okay, the representation of this symbol is, first of all, it should be represented in the square box. Okay, and then it should be on the white background, not on the any kind of the background. It should be on the white background, and then black symbol, whatever it may be, the hazard symbol should be kept inside the red square frame. That is the pictorial diagram, which is this diagram is following universally and which is developed by, that is the Occupational Safety Health Administration, OSHA, that is from United Safety. Okay, this is the presentation of the pictorial diagram for the safety of the any hazard symbol, which can be, first of all, it should be in the red square frame and which can be kept in the background, white background, and then followed by the hazardous symbol, whatever it may be the symbol. So now these are some kind of the symbols which you can see on our chemicals, in the chemical laboratory on the bottles, some toxic symbols, some carcinogenic symbols, some flame over the symbols. Okay, now I would like to discuss about the corrosion. Okay, so first of all, if you see the corrosion symbol, it is having the symbol which is looks on the left hand side. Okay, it causes, if it is, the symbol is displayed like this on the chemical bottle, that means it causes the skin corrosion and also the eye damage, and also this, if you want to use this kind of the metals, you should be very careful towards the metals because it can cause corrosion to the metals. Okay, what are the precautions to be taken care for this corrosive metals? Avoid skin you should use some kind of the gloves if you want to use that chemical, and better to use the lab coat and apron and handle it in the fume cupboard only, and must be stored below the eye level. It should not be stored above the eye level. Sometimes it is confused whether the chemical is present or not. That is why always it is better to store below the eye level that chemical. Okay. Some examples for this kind of the situation are, that is the acids and some kind of bases, oxidizing agents like nitric acids and others, and highly concentrated hydrochloric acid and sulfuric acids, and these belongs to the some kind of the corrosive metals. And what are the precautions we can take is we have to better to handle these chemicals in the fume cupboard. On the right hand side there is another symbol, that is an exploding bomb. Okay, that is some kind of organic peroxides, some kind of the sodium tertiary beta oxide, potassium tertiary beta oxide, in some cases magnesium tertiary beta oxides, which is formed in our in our reaction in situ. When you are adding the magnesium oxide plus tertiary beta oxide, you can get the magnesium tertiary beta oxide and some kind of lithium tertiary beta oxides. These kind of the peroxides are also very dangerous, and which can lead to the if the temperature is not if we do not maintain proper temperature, which can lead to the explosion of the little some small kind of the explosion can take place if you use it in a small quantities. Okay, and also these chemicals are highly unstable and highly unreactive. Okay, for example, whenever you want to use this kind of the chemicals like exploding bomb chemicals, that means that symbol is present on our chemical bottle. Okay, that is on the right hand side. Whatever I am saying it, exploding bomb, that is on the right hand side of the symbol. If it is present on our chemical bottle, we have to be very careful. That indicates that the chemical is containing some, it may form some organic peroxides, or these materials may be the self-reactive, or maybe the unstable and highly reactive. So some examples belongs to the trinitrotoluene and sodium azide. Of course, sodium azide itself is not really a highly reactive material, but when you take the sodium azide in the presence of an oxidizing agent, it causes some kind of the explosion in the laboratory, and which it causes the serious injuries in the person who is handling in the laboratory. Okay, that kind of the symbols you should know very carefully. And if you have any doubts before handling of those chemicals, just please ask your PhD supervisor or any senior professor or any other person who is assisting you. Then if you have any kind of questions, just don't use those chemicals directly. If you have any questions when you are using the exploding bomb, when the symbol is representing like the exploding bomb on the chemical. Okay. Some chemicals that is a strong basis, and also some kind of the strong acids when you are using those chemicals are the corrosive chemicals. Of course, those chemicals are very dangerous. If you even one drop of the sodium hydroxide, concentrated hydroxide fall onto your eye, okay, it is very, very dangerous. It can destroy the sensitive part of the eye, and even after a long term, it can be, you can lose your eye also. Eye power, slowly you can lose your eye power, and then slowly you can lose your eye also if you are very careless in the laboratory. Okay, so always better to use the goggles and gloves, and also the jackets. Better to use the apron before using the highly concentrated acids and highly concentrated bases in your laboratory. That is one of the precautions you need to take. Okay. So never try to add never try to add water to the acid, because when you are taking the titrations, or when you are preparing the one normal HCl or one normal sulfuric acid, or something like a HNO3 or whatever it may be, never try to add water to the acid, but always add acid to the water. Okay, it can give, because if suppose some kind of exothermic reactions are there, at least you can control it by adding drop by drop of the acid to the water. It cannot cause only it can cause some, it can generate some heating, but it cannot cause any kind of the damage to your laboratory equipments. Okay, it will, when you are using the bases, of course it causes more serious, because of they are capable of burning and corroding or even destroying the living tissues. Okay, always what is the safety precaution is for this is always wear the appropriate protective clothes, okay, that would prevent any kind of the acid or burn. Okay. So another symbol here, that is the toxic symbol. Toxic symbol, if the symbol is present on your body like this, that is represent the toxic. The chemical is highly toxic. Okay, so the toxicity can enter into your body by inhaling that chemical, or by if you are using by if you are taking that chemical by syringe. By unfortunately, if that syringe needle is on your finger or in your hand, it may enter into your body, and it total body can get the poisonous. Okay, so these kind of the things when you are handling, that better to always use the, and also you better to use the some not only the gloves when you are using the toxic chemicals, better to handle it in the fume cupboard, not to handle on the simple laboratory bench, but better to use it in the fume cupboards. Okay, they never. These are also the toxic chemicals. Are also some of the toxic chemicals are also, they are the flammable and also the corrosive. So in order to not only this, when you are handling the toxic chemicals, one of the problem is that is the females and males, both males and females may have the some kind of the what adverse effects. So you may not have the child, you may not get the kids even after marriage if you use the toxic chemicals very without taking the precautions. That is one of the dangerous sign which is recently established or recently developed by the American Chemical Society. And they have found that when you are using the chromium, nickel, formaldehyde, and isocyanates, we have to be very, very, very careful, because these are highly toxic chemicals. When you are using these chemicals in our laboratory, always better to use in the fume cupboard. If the fume cupboard is not available in our laboratory, at least try to use these chemicals in the ventilation, where the sunlight and ventilation is not in the sunlight, where the ventilation is proper ventilation is there. Better to use those chemicals in the ventilation. Okay, and always better to try to use in the fume cupboard if it is not possible. For example, in the some universities, fume cupboards are not available. Okay, in some colleges, private college, some colleges, fume cupboards are not available. Even gloves are also not available. In such a cases, we have to be very careful. We have to use these chemicals very carefully in the well ventilated and but don't directly expose those chemicals to the sunlight. In the ventilated areas, we have to use those chemicals. It may cause the serious health issues in the. So now, not only this hazardous chemical, we need to understand what is the hazardous waste. After doing the reaction, or after using the after doing any kind of the experiment in the laboratory, then we are having the some kind of the waste. This kind of the waste also contains some hazardous materials, like they may be the corrosive materials, they may be the flammable, or they may generate some peroxides in the waste, in the whatever it may be the waste. And so that when these materials are discarded, they should be when you want to throw those materials, just inform to your officers or your PhD supervisor just what to do, how to discard those. If suppose some acids are there in your waste, then better to neutralize it with the base. If the lot of base is there, then better to neutralize, or you can nullify whatever it may be, and make it as a neutral solution. And also, and one of the precaution you need to take is that is you have to check the peroxide test before disposing any waste material, because if the peroxides are there, it is very, very dangerous, not only the for the human being. When these water enters into the sea or into the river or wherever, or it enters into the some ocean, so some kind of the fish, if we find some kind of the fish, these kind of the fish, these can be destroyed if they take the peroxides immediately. So even any kind of the seafood, if you want to take in the means in the foreign countries, for example, they immediately test the peroxide. If the peroxide is there, it is very dangerous. Not only for human beings, it is also dangerous for the animals also. That is why before disposing of very in a large quantity, better to do the peroxide test. And if you have any questions, then you can ask your PhD supervisor how to dispose this kind of the chemicals. Okay, and some other chemicals which we can see, that is the escalation marks, which are also which we can see in our chemical laboratory. What is, and also some oxidizers, flammables. Okay, flame over circle. These are the some oxidizers, and also these oxidizers must be keep it in the cool place, and also which should not expose towards the sunlight. Okay, they can immediately get oxidized, and we can get some unreacted materials which can be generated from this, which may be the corrosive also. Okay, some another kind of the materials, that is the flammable materials, also we can see here. Flammable materials like acetone and methyl alcohol. These are also the very flammable materials which should be kept away from the hot sources. Hot sources means like a oven. When you are using the oven, don't keep the acetone or alcohol just besides the oven. Or any kind of the when you are doing some reaction at higher temperature, don't keep your chemicals just besides the flammable solvent. Just in the case of the water, for example, when you are using the sodium metal or N-butyl lithium, tertiary butyl lithium, you can see that is the water is present. Of course, on the water it has crossed mark in the horizontal way, so that we can see that we should not use the water when you are handling that chemical. That means that your reaction mixture should be highly 100% under the inert conditions without having even moisture or any kind of the small impurity. So that indicates that we should not use any kind of the water in that. This is the displacement of the naphtha also. Okay. So when we are going for the cryogenic hazards, okay, cryogenic hazard means that which are when we are handling the chemicals at the lower temperatures at -190 or -200 degrees centigrade. Okay, so which is having the oil melting point is very low. In such a cases, when we are handling the samples for the NMR, when you want to measure the NMR, we need the liquid nitrogen. When we want to measure the then also we need the liquid nitrogen. Such a kind of materials when you are using, you have to be very careful. Okay, so what is going to happen is when you are going, when it can when the such a kind of chemical fall on your skin, immediately it burns and it can become very red color. Okay, so in such a kind of materials, we have to use it under thermal insulation, like you have to use a Dewar flask, or you can use some kind of thermal insulated materials which are available in the laboratory. Okay, when you are using such a kind of chemicals, you should not forget to use the gloves. Okay, must and should, you have to wear gloves which are not the plastic gloves, which should be the cotton gloves. Okay. So immediately when the such a kind of chemicals fall onto your skin, it can immediately turn into the red color. Okay. So immediately you contact the medical officer when you face such a kind of problems. Normally, organic chemistry people normally they use to measure the NMR. When you are measuring the NMR, of course, liquid nitrogen is required. And when you are measuring the surface area, PET surface area, liquid nitrogen is required. When you are handling liquid nitrogen, when you are carrying out liquid nitrogen from one place to another place, you have to be very careful, and gloves must be there when you are handling this divar flask or anything. Okay, gloves means not, don't use the surgical gloves, but the gloves should be in the cotton gloves should be used when you are handling this one. Of course, it is having it boils at minus 196 degrees centigrade. Okay, if you consider another cryogenic liquid, that another cryogenic system, that is the acetone and dry ice, which is also having the minus 80 degrees centigrade, and these two, liquid nitrogen and also the dry ice acetone system, is having the high heat capacity. Both of them are having the high heat capacity, and also high specific gravity is also very high for these kind of the molecules. For example, in the case of the liquid nitrogen. Okay, so if it is possible, when you are doing the reaction, better to use the dry ice and acetone instead of the liquid nitrogen. If it is available dry ice and acetone, then better to use the dry ice and acetone for when you want to do the reactions at the lower temperatures. Better to avoid use of the liquid nitrogen. And if it is required, if it is necessary, then you can go for the liquid nitrogen. Okay. So then we can see some kind of the biological hazardous also. Biological hazardous materials or some kind of the materials which can cause the harm to the humans, not the animals and plants. Okay. This is coming from the waste from the animals, bacteria, and also from the humans. Okay, the symbol is represented like this in the circles, in the one circle over one circle. Above that, 3 circles are represented in the form of a triangle. Okay, that represents that our chemical, our whatever it may be, the material is having the biological hazardous chemical. Okay, if you take the biological hazardous material, if you inhale it, or it can transmit through the injection or whatever it may be, then you can get the respiratory problems and also transmission through contact with the body, and you can get these kind of the materials. If you inhale it or if it enters into your body, you can get the serious kidney damages also. Such a kind of materials you can avoid. Be careful and better to avoid such a kind of the materials, and better to handle it. Better not to handle without having the proper safety instructions in the laboratory. Okay, and also you can also face some allergy, and also some kind of the urine infections can also be observed when you are having such a kind of biological hazardous material. And one of the most important thing is, when you are handling the biological hazardous material, better to take at least 1 liter of the water before entering into the lab. Okay, because that can avoid some kind of the urine infections when you are handling the this biological hazardous. That is the safety precaution. One of the safety precaution that you need to take at least minimum 1 liter of the water. Okay, then you do the experiment. Of course, any kind of the experiment before doing you want to carry out any experiment, whether it is the kinetic experiment or the organic experiment, or when you are doing analytical experiment, whatever it may be, before entering into the lab, just take the 1 liter of the water. Okay, then some kind of the balance, some by mistake, if you inhale some kind of the acid, some kind of the base, or some kind of some materials, okay, it can balance or whatever it may be, the materials or chemicals you are taking. Okay, in addition to the safety precautions, better to take at least some kind of the urinary infections. Okay, you take at least 1, and also I would like to discuss about what you don't do in the laboratory, what you have to do, don't do in the laboratory, particularly research students, those who are doing the PhD. And also MSc students, those when they are doing some experiments, particularly in the kinetics and also in the thermodynamic experiments, kinetic experiments takes long time. We need to take the V naught value, V20 value, V30 values. Then we need to find out what is the V infinity value. So in between we are having the 10 to 15 minutes time. People use it to take the some kind of the snacks or some kind of the drink or whatever it may be. Don't eating and drinking in the laboratory is strictly prohibited. Don't take any kind of the meal in the laboratory. Okay. And don't do any personal kind of the work, so just grooming your hair, and also don't do any kind of the celebrations like birthday celebrations or any kind of the celebrations in the lab when you have the small time. Okay. And minors which are having the below 14 years are strictly prohibited in the lab because they don't know what type of the chemical they are touching. If they see that when we are doing the reactions in the presence of the nitrogen atmosphere, we are using the balloons. If the one guy came which is having the less than 14 years, this is the balloon people are using. This is he don't know that what is the importance of the nitrogen that which we are using in the for the reaction. He may take out that balloon and he can see that we can play with the balloon. Okay. So sometimes oxygen in the presence of oxygen also we are doing the experiments by taking the balloons. Okay. So not only the balloons, when students under the below the 14 years, they don't know what type of the chemicals, whether it is a harmful chemical or toxic chemical or whatever it may be. So simply they want to touch the chemical. So that is better not to enter minors before under the age of 14 years, strictly prohibited to enter into the lab for the safety point of view. Okay. And remember that laboratory is not for just for fun, because laboratory is a place to work very seriously. Whether if you are so don't try to test even the water from the, don't try to drink water even from the tap water from the laboratory. Okay. Precaution you should take care is that don't work alone in the lab. When you are alone in the lab, no need, better to avoid to work in the lab. Okay. Until you can read some reading or journals or like that. If you but if you want to do the laboratory work, doing some kind of the reactions or some kind of the heating, better not to do the laboratory work alone. If something happens, who is going to protect you? Nobody is there to protect you. but you can do the work just like reading the research articles, or you can put the test tube towards your mouth, it may cause serious health problem to you, and it may cause serious health problem to your colleagues also. Okay, be safe when you are handling, and don't pipette the solutions by mouth. Okay, don't take the solutions like a KMNO4, acid, bases, nothing. Don't use don't use any kind of the solutions. Okay, better to always use the pipettes and using the rubber balls to, because I observed many students for MSc or BSc students when they don't want to do practicals in a hurry, just they want to do the practicals in a hurry and they want to leave the lab. In such cases, even they don't want to go and ask the attender just for the bulbs or any other thing, micro pipettes or anything. Just they want to suck the chemicals by mouth, and it may create some kind of injuries for you. Okay, so wash your hands with the soap water before leaving. Even if you wear the gloves also, don't think that I have wear the gloves, nothing is going to happen. No, even the gloves also sometimes it contains some chemicals for the storage purpose, and because it is a plastic and it is a kind of the polymer. So when you are using the handle, when you are handling with the acids and bases, uh, it can be deteriorated, and it can lose its polymerization properties, so that you can get your hand maybe contaminated. So that better to use your handles, your hand very carefully before leaving the lab. Okay, these are some kind of the labels. So of course you need to understand what is the label contains and read it carefully, and you interpret the data from the MSDS, what type of the chemical it is, what is its physical properties, what is its reactive properties, chemical properties, and all. Okay, and never discard the unwanted chemicals in the sink. Sink is not sink. Don't throw your chemicals simply into the sink. Okay, just first try to neutralize the chemicals, and second thing is try to test the peroxides formation, whether the peroxide is formed or not. And also another important parameter is the sharps safety. Sharps safety means here we are sometimes we are using the sharp like syringes and needles in the laboratory. Capillary tubes and sharps we are keeping just throwing on the dust, on the simple dustbin or on the floor itself. It is not good for us to, if you throw the capillary tubes and the simple syringes. Okay, these may cause the some kind of the injuries to you, and so that better to drop it in a particular boxes which you label with the sharp sharp kind of hazardous materials like syringes, capillaries, and any kind of the glass, broken glass wares are there, which you can throw it in a specialized means labeled dustbins. Okay, and the laboratory should be very hygiene. Okay, don't touch your fingers and don't try to remove your nails in the laboratory. It is very dangerous and it can harm you. Okay, and always wash your hands and before leaving the lab. And this is the statement by the Professor Robert Grubbs. Okay, we rapidly search important chemical information while an idea is fresh in your mind and is almost priceless. Okay, before going to start any kind of the research, better to search what type of the chemical you are using and what type of the material you are using and how it is going to be effective or carcinogenic, and all these things better to understand the kind of the materials. Okay, my conclusion is take the precautions, follow the safety rules, and enjoy your research. Okay, it is a passion, but it is not a degree. Okay, it is a research. Doing the research, it is a multifaceted talent, not a like if you study the MSc and other things or MCom or whatever it may be. So it is a kind of a one direction, but research is not in one direction. It is a multifaceted talent. Okay, you can if you give the more time in the laboratory, and you can get the better result, and you can expose towards the more chemicals, and you can handle it more in a more safety manner. Okay, there is nothing cooler if you find the really the good thing in your life, at least one new thing which is not known earlier. Okay, that is the contribution. Nothing is cooler than that one. That is the really gives you very very happiness. You cannot get more happy if you find the really the new things in your life. Even if you find the new reactions, or if you find the new chemical or new properties of the chemical. Okay, if suppose some property is not known earlier, if you find some property of the chemical, like a refractive index is this one, or surface tension is this one, or if you find the viscosity of a particular unknown chemical, okay, that gives you the lot of boost energy to you, which is not known earlier. Okay, so try to find out the new things and try to be careful and be safety and enjoy your research and also practicals in the laboratory. And thank you very much for giving me this opportunity once again.
Thank you, sir. Thank you very much, sir, for detailed informative talk on a useful topic, hazardous material and their significance. Thank you very much. So now that session is open for a discussion. So anyone have questions, please ask.
Professor Ranganathan, it was nice listening your lecture. Actually, it's a beautiful kind of delivery.
Thank you, sir.
Congratulations for that. I have a little question regarding, because we being a state university like institutions like ours, we do not enjoy much of the funds available with us and spending. I mean, in fact, the money on doing such kinds of things regarding, which is very important actually. But then we, due to the lack of the economic, I mean, the finance or all that, we normally ignore these things. So my point is, your institution being you are at the Central University, how do you do this? How do you enjoy such kinds of laboratory safety practices?
Not in all the cases, sir, but in most of the following.
All right.
And not when we are using some kind of the chemicals, at least we are following, but not for all the chemicals. Still, we are trying to do, bring some kind of the equipments to the laboratory.
Right.
Still, in our laboratory, still we don't have the very fume cupboard we have, but not, it is not really hygienic fume cupboard. It is just only just like our almirah in our at home, just such a kind of fume cupboards we are having, but not really, it is not really exhausted, the ventilation and exhausted, it is not having. We are also facing such a kind of problems in our university. Slowly, step by step, we are trying to solve this.
So even students working in laboratory, we do not have yet developed a kind of system to tell the students that not to pour in the sink, as you said. It's very dangerous when it gets percolated into the ground, deep water aquifer. So the water will not be potable. So these sorts of the things. So we actually we all know the things, but we do not bring it in the practice. Actually, this is the point.
Yeah, that is, I agree completely with you, sir. So in such a cases, maybe we should ask the students better to bring their own water, or we can ask the university authority at least provide one water cooler in the one department. At least in one department, one water cooler should be provided in such a cases. So at least students can have students can drink their water and can take their water.
All right. Thanks to the UGC. That NAC accreditation committee from time to time when they come for the survey, and they suggest to have a kind of fire extinguisher in the laboratory, first aid box, and all those preliminary things that is required in the laboratory.
Yes, sir.
So this is basically we forcefully do the things with not of our own actually. Oh,
yes,
unless we try bringing up these ideas, and the thing is that from macro to miniaturized experiments with green chemistry experiments, we need to convert into in the laboratory, not using much quantity of the chemicals. So this would be the idea basically actually.
Yes.
But then we still have not yet developed here. Not mentally, and not that we have the facilities even available for the students. So more questions are invited. Participants, please, from the student side, I would like the students to ask questions. MSc students, Dr. Kamlesh, MSc students are also connected. They are through YouTube, I believe. No? Mostly they are connected through. They cannot directly interact, I believe. Unmute, Dr. Srivas, unmute yourself.
They have joined in a YouTube, sir. They have joined in YouTube.
Okay,
This is maybe I think we should also put here.
Yeah. All right. Hello, sir.
Yeah.
Hello.
Yes, please tell me.
Can I ask, sir, your question?
Yes, sir.
Very good.
Yeah, please tell me, sir.
How we can differentiate which one is better safety now? Hello?
Sir, I did not get you. Can you please ask again?
No, before 40-year laboratories and nowadays laboratories, how differentiate which one is more safety? Hello.
Yeah, so you are talking about the no, sir, some voice is breaking, sir. Just
I put question in a chat box, sir. Hello.
yeah.
Hello.
Yes, sir. I am hearing you. Just let me. Yeah, tell me.
I put question for 40-year laboratories and now laboratories. How you differentiate? Hello. Hello, sir.
Hello, hello, sir. I think
Kamlesh,
hear me,
can
sir?
you just yeah.
I think maybe sir, that please Pravasji, please put your that question in a text box because I think it is very difficult to listen you. Maybe other people can ask question. Other people can ask.
Because your voice is breaking.
He has put in his I mean a message there in chat box, and the text he has typed in is before 40 years laboratories.
Yes, sir.
And present laboratories. How you differentiate which one more safety? I really could not get the point actually. If you Dr. Ranganath, you can answer to his question.
Right. So when we are doing reactions in the laboratory, we are doing the reactions under the nitrogen. Of course, in the like a very highly sophisticated laboratory, we don't use the balloons. But in our laboratory, we are using the balloons. Reactions under the nitrogen atmosphere. Okay, when you are using the doing the reactions under the inert atmosphere, when you are using the balloons, if suppose some person is entered into the laboratory, like a boy which is having the 10 years or 11 years old, he can see that some balloons are there, so he don't know why we have kept the balloon or what is the purpose. So he may take that he may take away that balloon and he may press that balloon. So what it is and how going to affect, maybe he want to burst that balloon. Okay, in such a kind of cases, we cannot control on the spot. It may happen in a fraction of seconds. Control that one. That is why it's better to avoid. And always the person who is elder people, if you enter, if at least they will ask us, oh, what is this one? Why are you doing this? What kind of the reaction? Anything they can ask. But childs and kids, they may not ask you direct kind of time to give the answer. What kind of the things we are handling in the lab. I suggest better, because we are using some kind of syringes also in the laboratory to take the solvents and chemicals. They may think that this is the syringe for doing some kind of the injections. It looks very funny, and they may touch it and they can do some kind of the they can get some kind of injuries. So that is why due to all these things, better to avoid to enter into the laboratory.
This is Inner Power University. So how do you dispose heavy metal like cadmium, arsenic, mercury? Because this heavy metal are really toxic for many people.
Actually, I am not the right person because I have never used those kind of materials. Maybe you could have asked Professor Tyagi sir for the person, because he was using such kind of materials.
Thank you, sir.
Dr. Indrapal, if you ask me this question better, I have a kind of suggestion, although I have not gone through all these things. If you are working with a bulk quantity of heavy metals, then there must be some mechanism developed in your laboratory itself, which can give you back, the recovered amount of the heavy metals. This has two advantageous features, I believe. One is that you are not disposing of it directly to the ground or somewhere else into the atmosphere. Second thing, you are getting it enriched amount of the heavy metals, which are not, toxicity is something different, but they are costly even. So you can recover it from your own laboratory. So there should be some mechanism if you are working with a high quantity of heavy metals.
Thank you. Thank you, sir. Thank you, Gannath sir. Thank you very much for coming and delivering lecture here. And now we reach to end of this webinar. Go, sir.
Yes, you can conclude. Vote of thanks and
conclude. So
I think.
So thank you very much to everyone for joining this webinar. I, on behalf of Organizing Committee, Chemical Research Society of India and Local Chapter Chhattisgarh and School of Studies in Chemistry, Pandit Ravishankar Shukla University, and I, on own behalf, convey deep regards and thanks to Honorable Vice Chancellor, Professor Kestilal Verma sir, Pandit Ravishankar Shukla University for his present and logistic support for this webinar. We also thank Registrar Sir Professor Girish Kant Pandey, Pandit Ravishankar Shukla University on this occasion for his kind support. I also convey thanks to Dr.
Kamlesh.
Sir.
Now we did this, webinar. Professor Kallol Ghosh has given a lot of time. And
no problem.
Useful, very much useful. So, what is your plan? What should we do? Because it should not be only a webinar. Because they told a lot of things, and we have to implement in a minimum start from our laboratories to all stakeholders here from different colleges, institutions. I think people have to speak what they will plan for laboratory safety and chemical safety. I think some from us, from other colleges. But this is very useful and they will give a job.
Can I speak a little about it? If I am permitted.
Yes, sir. Yes, sir.
Yeah.
One information that all the participants.
I remember the period when Dr. Indrapal Karbhal joined our department as faculty member in around 2016 or 17, I believe. It's already crossed 3 years of his services. Yes. Now, point is that when he joined, when he was working in NPL, and he has all the experiences there, Pune NPL. And when he came back to join as faculty here at our department, I saw him distributing his gloves to the students for making, organic synthesis. And by his own, he gave, distributed the masks to wear to the students. So this is a kind of thing which, is to be appreciated all the time. And it is not that all the time your head of the department will tell you. It is not all the time that the vice chancellor or SOPs will tell you. Basic thing that comes from is from your own contribution. So this way I have seen him working for the laboratory safety procedures, and this is a good thing. A good kind of platform. I must appreciate the efforts made by Dr. Indrapal Kar. So this little effort by all individuals could support in this way in bringing this very important issue in the laboratory safety. So thanks to Dr. Karbhal for bringing this kind of practices here in our university. So this is his, but then there is some kind of limitation also. One cannot of his own, make large expenditures. So there must be some support unless the university or the state government funds give the funds for doing such kinds of very important, because all the way it is related to human health and it must be taken very good care of it. So thank you very much for allowing me to speak about this.
I think Dr. Dev, just during this delivery, I had talked with the Dr. Indrapal, and we decided right now, to arrange a room in our department for a toxic chemical waste disposal laboratory, and that laboratory will be led by Dr. Indrapal, and he will make his team with other colleagues. So I think this is the outcome which we did immediately after the talk of Dr. Tyagi and Dr. Kalluri. So Ghosh sir, just I want to convince Ghosh sir that this webinar is very fruitful, because we decided to start a separate lab for disposal.
Very good, very good, very good.
So similarly, I think other participants here from our different colleges, what they are pledging, tell me, just we want to know. If people are conveying thanks, but like Prasanna, Dr. Prasanna, what we are going to plan now? It should be impactful now if we arrange the talk from such a busy people. So a lot of people from other. Yes.
Sir, I can hear now. Yes, sir.
Yeah. So, do you have any plan?
Sir, we have been already started with the primary education to our students for hazard waste management, and
very good.
And as a part of syllabus for the upcoming session, we are also having some industrial visit for the safety precaution. But in fact, the laboratory, all precautions have been done as the primary level. But as per your suggestion, I just appreciate you, sir. You have given a very, very, very nice suggestion to make all necessary arrangements for the precaution of each and every toxic chemicals inside the laboratory. So definitely, I will be with you, and we can do any plans.
So here, a lot of experts are here in this webinar. So if anyone get any new idea of management and safety management and disposal management, please share with all of us, because we have already a WhatsApp group of Chhattisgarh chemical folks. So you can share, you all can share, we will also share, so that combined effort will make us make it possible to arrange the disposal center, scientifically disposable centers in every institution. Thank you, Kamlesh.
Sure, sir, sure. Good idea. Very nice idea. Thank you.
Thank you, Kamlesh.
Yeah, go ahead. Okay. So any suggestion from any faculty member? So it is a welcome. So go, sir. Please, you have some suggestions. So okay, thank you. So I will continue with the vote of thanks. I convey thanks to Dr. A.K. Tyagi, State Director Chemistry Group from Baba Atomic Research Center, Mumbai, who acted as a distinguished guest and a speaker of this webinar. I am sure that his address will provide a wider base for understanding safety in chemical laboratory. He told about risk management, accident prevention, and also told about the relationship between a hazardous material and risk. He also told about the different preventive steps for a prevention of a different chemicals. I also thank Dr. KVS Rannath sir from the Department of Chemistry, Banaras Hindu University, for his highly useful talks in terms of a telling nature of a nature of properties of different chemicals, and also health effects of those chemicals. He also told about that how we can understand the hazardous materials in the form of pictograms and labels, and also told about the different preventive actions that we are using in our laboratory. Also, sincere thanks to distinguished participants who are from different colleges, universities, institutes to attend this useful webinar. We are also proud of active participation from research scholars and students. I also thank Chairperson Professor Sank Parvez, Head School of Studies in Chemistry, Pandit Ravishankar Shukla University, Coordinator of CRSI Local Chapter, Professor Kallol Kumar Ghosh, Convener Professor Manas Kanti Dev Sir, Organizing Committee members Dr. Manish K. Rai, Dr. M.L. Satnami, Dr. Indra Paul Karwal, and office staff and research scholar of this department for their support and help to make this webinar successful. Also, my sincere thanks to Mr. Tej Bahadur Chandra and his team for electronic support and coverage of this webinar. At last, we hope that this webinar will help to understand the level of safety being using in our lab. Thank you very much.
Chancellor is here online to give concluding remarks if he
आया था, उनसे भी चर्चा कर रहा था, क्रिया थी उसमें सिग्नेचर कर रहा था, डिप्टी रजिस्ट्रार असिस्टेंट रजिस्ट्रार आए थे, कुछ उससे चर्चा करता रहा, सुनता रहा, आम रहा, लेकिन भी कहा कि हमारा जो केमिस्ट्री हमारी अध्ययनशाला है, केमिस्ट्री अध्ययनशाला, वहाँ जब भी कार्यक्रम होते हैं बहुत व्यवस्थित और अच्छे होते हैं, उपयोगी रहा। मैं सुनता रहा, जो पावर पॉइंट प्रेजेंटेशन चल रहा था उसको भी बीच बीच में देखता रहा, अच्छा लगा। लेकिन एक बात जो मैं कहना चाहूंगा, जिसका उल्लेख शुरू में हमारे स्पीकर ने जो बात की, त्यागी प्रोफेसर त्यागी ने, कि यहाँ एक सेफ्टी के लिए कमेटी बनी है, काम करें इसका, ये उन्होंने कहा है। और अगर ऐसा प्रस्ताव आता है तो हम उसको स्वीकृति देंगे, क्योंकि अब जीवन का जो महत्व है, सुरक्षा का जो महत्व है, ध्यान देने की बात है। काम तो कर रहे हैं, सुरक्षित रह के काम करें, ज्यादा महत्वपूर्ण है। मैंने पहले भी उल्लेख किया कि जब भी मैं भिलाई स्थित प्लांट देखने जाता हूँ, बार बार सेफ्टी की बात, और पहले से स्थिति और बेहतर होती चली जाती है। प्ले करते हैं, बताते हैं, जानकारी देते हैं, और प्रारंभ से ही ट्रेनिंग देते हैं। अगर आप उसमें प्लांट में एंटर कर रहे हैं तब कैसे एंटर करेंगे, और उस प्लांट में जिस भाग में जा रहे हैं और काम कर रहे हैं वहां अतिरिक्त और क्या सेफ्टी
एक बीजे और